Remembering our primary objective here is applicable, practical music theory that helps us to actually play our instrument better. For us, that instrument typically being the guitar. However, the same concepts do apply for other instruments as well. We want to learn music theory in such a way that it not only helps us to learn the basics, but is also scalable. In other words, we want to avoid learning rules that only apply to the basics, but aren't actually true once we expand our knowledge and understanding. So to do that, however, we got to dig a little bit into the science of music, which is basically what we're doing here. What is sound? What do the notes actually mean? And I think that is going to be applicable in particular when we think about some of the ideas that we take for granted, that we take a priori when we start to build our worksheets. And we do want to understand and think, hey, what does this mean? How did they come up with this? Two primary examples, for example, are the note names. Why is an A an A? Why is a C a C? What are those things? We're just accepting them a priori. There's 12 notes. I'm just accepting that and then moving forward with the music theory. We'll get a little bit better understanding of what that is here. Also, and this one's a little bit more complex, we just accept a priori in Western music the formula for the major scale that also leads to the construction of the modes, the whole, whole, half, whole, 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 half. Where does that come from? Why do we use that? Now, we might not get to that exactly in this presentation, but we're going to lead into at least some ideas as to why they came up with that scale function or formula as well. All right, so what's the definition of sound? A vibration that travels through a medium, typically air, and is perceived by the ear. So when we think of sound, it's kind of hard to envision sound, and envisioning as human beings is what we typically want to do because we're mainly visual kind of animals here. So that's what we'd like to see. So we envision basically a wave, which you can compare to a water wave, noting that a water wave is traveling through what we call a medium, which of course is the water in that case. The sound is also going through a medium, which is the air. It's harder to envision that it's traveling through air. There's nothing there. It's just air, but it is something there. There's an atmosphere here. There is not an atmosphere, for example, in space, which is why some sci-fi critics and whatnot get upset when something blows up in space and you hear this loud sound and they're like, well, it's in a vacuum. There's no medium for the sound to be traveling through, so that wouldn't be the case, and so on and so forth. So we have to envision that there's some kind of medium there. That also leads, by the way, to some other concepts that you might have heard of, like scientifically, like the ether, where they said that everything has to have some kind of ether, even if there isn't an atmosphere. There's got to be something because things travel through empty space, like light possibly is still going. Light has to be a wave or a particle, and so on and so forth. And then if you hear these concepts, then of course, once they go out of the scientific realm, you also hear them in like spiritual realms. You hear these kind of concepts that are all this idea that you would think that everything's kind of connected or has to be traveling through something. So there's this tendency to want to say there's got to be something there, a medium that's going to be traveled through. And that basically comes from this concept often of waves that we see water traveling through, that we see the sound traveling through. So it requires a source, medium, and receiver. So what do we need to basically define sound? Well, there has to be a disturbance in the force, right? A disturbance in the air molecules in this case by the plucking of a guitar string, for example, which makes the air molecules move, which we can imagine that movement, if we were to visualize it, something like dropping a pebble into a stream, that a completely lake, a nice still lake, the pebble drops in, the waves then are going to be emanating from that. That's what happens from the guitar traveling through the medium of the air. You have to have air so it can travel through if we're talking about sound, right? Light gets a little confusing. When you get to light, is it a particle or a wave? I don't know, it's a little more confusing, but the sound has to go through the air as far as I know, and then it's got to hit something, and that's the receiver, which is usually an eardrum, which leads to the good old question of what if a tree falls in the wood, no one's there to hear it? You don't have that last bit of the definition, someone receiving the wave. And that's why you have the question that leads to the paradox, and you become a Buddhist monk after hearing it, because you're like, whoa, dude, like something's crazy with that.